Alkenes and alkynes. Let's take a look at the alkenes first. Alkenes are compounds that contain a carbon-carbon double bond. The general formula of an alkene is CnH2n, where n is the number of carbons. The simplest alkene is ethylene, since each carbon of ethylene is surrounded by 3 atoms. Each carbon is a trigonal planar. All 6 atoms of ethylene lie in the same plane, and all bond angles are 120 degrees. This is what it looks like. In ethylene molecule, the 2 carbon atoms and the 4 hydrogen atoms. All those atoms are on the same plane. Next, let's take a look at the alkynes. Alkynes are compounds that contain a carbon-carbon triple bond. The general formula is CnH2n minus 2. Acetylene is the smallest alkyne. Each carbon of acetylene is surrounded by 2 atoms, making the molecule linear with the bond angles of 180 degrees. Look like this. In contrast to alkenes and alkynes are unsaturated hydrocarbons containing fewer hydrogen atoms than the maximum number of hydrogen atoms per carbon. Like alkenes and alkynes are water insoluble. Let's take a look at the nomenclature of alkenes and alkynes. The alkane is identified by suffix ene. Alkyne is identified by suffix yne. IUPAC naming alkenes and alkynes. First, find the longest chain that contain carbon atoms of the double or triple bonds as a parent chain. Then count the carbon number and use ene ending for the alkane and yne for the alkyne. Then number the carbon chain from the end that gives the location of multiple bonds a lower number. Number and name the substituents and write the name. We have 2 examples here. This one is 3-methyl-1-butene. 1-butene means this is 4. This parent chain, the longest chain is a 4 carbon and has a double bond between C1 and C2. At C3 position, the methyl group. This one is called 4-ethyl-2-hexane. That means the longest chain. It has a 6 carbon and 1 triple bond between C2 and C3, so it is called 2-hexane. At the C4 position has an ethyl group. Compounds with 2 double bonds are called dienes, using the suffix adiene. Take a look at the examples. This molecule called 1,3-butadiene. 1,3-butadiene this molecule has 2 double bonds. One is between C1 and C2, another one is between C3 and C4. Therefore, they called 1,3-butadiene. This one is a 5-methyl-1,4-hexadiene. These 2 double bonds in this 6 carbon chain Those double bonds are located at C1, between C1 and C2. Another one is between C4 and C5. On the C5 position, there's a methyl group. In naming cycloalkenes, the double bond is located between C1 and C2, and the one is omitted in the name. The ring is numbered to give the first substituent the lower number. Take a look at the examples. This is a 1-methyl cyclopentane. This is a 5-carbon membrane, has the double bond between C1 and C2. On the C1 position, there's a methyl group. This one is the 3-methyl cyclohepene. It's the 7-carbon membrane, the double bond between C1 and C2. On the C3 position, the methyl group. This one is 1,6-dimethyl cyclohexane. The ring is 6 carbon number, has a 6 carbon number with a double bond between C1 and C2. On C1 and C6, there's methyl groups. So they call it 1,6-dimethyl because it has 2 methyl groups on this molecule, cyclohexane. The simplest alkene is called ethane. CH2 has a common name called ethylene. The simplest alkyne, CH, ethine, has the common name called acetylene.